and today I'm going to show you about the structural loads and combinations about the analytical model, and this is going to be the last class of your Revit structure. So I have this structural model ready. So let me go to the 3D view, and here you can see that I'm getting some analytical lines with my 3D model because this option, this show analytical model option is checked. This is for analytical model. So if I click on this hide, it will not be visible anymore. And if you click on this show analytical model, so with your 3D model, the analytical model will be visible. And for this analytical model, we have this particular analytical model option available here. Okay. And here, if you go for the visibility graphics, and there you can see that this no model category views option is visible here. So it is unchecked, and only the model category, analytical model category, these kind of analytical models are visible here. So you can create also with this option, go to the visibility graphics, uncheck the model, uncheck this model category, uncheck it, and just check this analytical model categories. Don't check this one. Only the analytical model categories will be checked. So can just have. So this will be applicable for your structural component, the structural model you have created. Fine. And we have this analytical wall and these floors and this column. Okay. And these beams are there, analytical beams you can see. Now let me go to the structure tab. So for these, let me go to level 1 and all. And if I have this detail level course, you see that when I have this detail level course, I get this symbol for this structural framing. For this column, I'm getting this symbol, right? So how I can control this symbol when I have this detail level course? So for that, go to this structural settings. And there you have the symbolic representation settings. And not only that, we have some more options for load case, load combination, analytical model setting, boundary condition settings. I'll come into that part after this option. So here you can see that symbolic representation setting option is there. And you see that symbolic cutback distance for brace, for beam or truss, for column. This is the value. And for brace symbols, if you have applied any braces, so for that the plan representation is there. Okay, what and there is a parallel line offset is provided. Okay, and for connection, this is the symbol. This will be visible. And connection type, this is going to be the annotation symbol. Okay, and let me click on OK. So this is the default condition. Fine. This is a default condition. Suppose if I apply any braces, let me show you that. So for placing any braces, what I'll do, I will go with the framing elevation. So I can apply this framing elevation. So this framing elevation will be visible. The elevation view will be visible to grade 2 to grade 3. Right. So this is for particular view for this to this grid. Okay, so here you can see that we have this handle and you can change it from this to this. You can change it. So let me go to this elevation view. And here you can see that from the grid 2 to grid 3, the elements are visible. And here we have this detail level course right now. So this is for your structural framing. So here you can see that you are getting these lines. You can go for this fine detail so that you can get a 3D model with proper thickness and all three-dimensional aspects. Now, if you go to the structure tab and choose the brace, I will go with this default one. So I'll go to this level 2. Here I will place it, the level 2. So from this end to this end, and from this end to this midpoint. Okay, so it is placed. And let me go with MD to escape, or you can press double escape, and then you can stretch it till the midpoint, and you can stretch it till the midpoint. And after that, what you have to do it? Can anybody tell me what you have to do it for cutting this extra portion?
Coping.
Yes, right. So you can go to the modify, and there you have the scope option. Select this one first, and then select this one, and this is scoped. Similarly, do the same. Select this first, and then select it. Scoping is done. Okay. So this is the bracing which you have created. And if you go for this course, and you will see that this is the symbol. Okay. And now if you go to the level 1 where it is placed, level 1, and uh, let me go to level 2. Okay. Okay, so from the level 2, you can see that I'm getting this. These are the uh, bracings which we have created, this one and this one. Sorry, this one and this one, which we have created, right? So we are getting this symbol in this detail level course. So for that, you can choose this structure connection settings. And here you have this parallel offset, parallel line offset. So from the center, you are getting this offset. So you can choose how much offset will be there, like 6 inches, and you can click on OK. And you cannot see it, right, because of this shaded hidden line visual style. If you go for wireframe, I think you will be visible. So it's just not visible. Let me check here. And this is the brace above. Click on OK. So it's because this is so let me give it more. Let me give more. Uh, so let me give like 1 feet. Click on OK. So here you can see, right, 3 by 32 is the value. So it's like very less value is there. So let me go for like 1 inches and click on OK. It's not showing. Okay, so go for like 0. Uh, Let me go to fine, and these are there. And if you go for wireframe and course, so this should be generally on this. So let me go for tab here. Yes, so here you can see that this is the structure framing, which is right. No, no, this is not the right one. Just a second. Yes, so this one. So here you can see that these are kind of overlapping. So that's why we generally provide this parallel offset. Okay, so that we can understand 3 by 32. Okay, and this one is right now show brace above option is there. So currently I'm in this level 2. So we are generally looking it down because this brace is present in level 2, right? Sorry, level 1. So I'm currently at this level 2 and I'm right now looking uh, down, right? So here it is available. And if I go to this uncheck show brace below and click on OK, so it will not be visible. So the same thing, you can go to level 1 and there you can check or uncheck this show brace above. Okay, so these are the settings for your symbol. And now let me go to 3D there. And if I activate this analytical model visibility, okay, so now you can see that this analytical line or the analytical brace for this for this structural model, this is the endpoint is slightly off axis, right? The endpoint is slightly off from this model. So for that, go to this analytical model settings, and here you can see there are some tolerance analytical to physical model distance. Okay, so generally we provide, otherwise, it will merge and we will not able to see those. So that's why we generally provide this. So here we have all these things. So for member supports, there is some automatic checks and all. So you can activate this. So do you want to run Revit an analytical model check at this time? So if you go for yes, it will take much time. So I'm not going, I'm going for no. Go to analytical model settings and there you check for all these settings, member support check, analytical physical model consistency check, okay, analytical model connectivity and everything. All right. So after that, now I'm not changing in that tolerance option because we need the tolerance. I'm going to show you that without changing that also, how can you change it? So I have selected this analytical braces. And here you can see that the start alignment method is auto detected and end alignment method is auto detected. So this is the start point, but for this start point, this is rightly connected. This is rightly connected. And for this end also, you can select it and you can increase it like this way. And you can apply the coping option, go for modify, cope, select this and then select it. Okay. Cope, select it and then select it. Okay, so it will not cut. No worries. It's fine. Okay, so this way we can do it. And now let's come to this analytical brace part. So select this, and then come to this start alignment method. So the start alignment method is right now as per the auto detection, it is correct. But I will define the projection so that it will maintain the center. And for the start alignment and end alignment also, I'll go for projection. So as per this model, it should be projected at this midpoint, right? So there it will be uh, connected. Okay, endpoint will be connected in that projection endpoint. So similarly, I have to do the same for this analytical braces. So end alignment should be projection. And as I'm mentioning for this projection, so it should be projection for this start alignment method because I don't want to like if I change anything, it may happen like again it may detect another off axis. So that's why I have mentioned this uh, alignment method projection. Similarly, you can go for Y and Z projection. So location line that is uh, the center right now. Okay, fine. So this way we will fix it. Now we have some loads and some supports also. So let me go to the analytical model. And for your structural members, you need some boundary condition. Okay, so for that, go to Analyze tab, and there you have this boundary condition. You need to define it is the boundary condition, the point or line or area. So you go for this boundary condition and then choose the boundary condition as it is a point or line or area. So I'll go with this point because at this point this is fixed or this is pinned or what kind of support is it. So you can choose fixed, pinned, roller. So you all know that. So this is going to be the fixed and orient to project. This is going to host with local coordinate system. So it's going to be project. So select on these points. So this is very easy. Just click on it. Right. So this way we can do it. And if you have any supports here, so you can go for line supports. You can choose this line, and this way you can provide any extra supports if it is there. So this way you can choose the line and you can provide it. So right now it's not needed. And for area also, like for this floor, for this analytical floor, you want to provide the support. So these supports can be provided. So you can choose like this is going to be the pin support or user. So here you can provide like in the X, it will be fixed or it will be released. So free end support, you can provide the rotation. So for this also you can like go for this user and you can release in the X, Y, and Z direction in which direction it will be released. So you can provide that. Okay.
So X and Y release means there was no load. Okay.
Yes, right. So generally it will be like in the X direction it will be released, and in Y or Z it will be fixed, or in the Z direction. As per the Z, it will be like released. So this way you can provide. Just showing you as per the right condition, you can change it. I'm just showing you the this is the location where you can change all these things. All right. Now we will apply some loads. So how can we apply loads? So for that, we need to define loads. So you can go to this load cases, and in Revit we have uh, 9 type of typical loads. Okay, so from those types only you have to choose. So here you can see that accidental loads, dead loads, live loads, roof live loads, seismic loads, and snow, temperature, wind loads. These are available. Okay. Okay, so here you can see that eight types is available. Okay, so you cannot create the category, but you can define the load nature. Here you can create the load nature. So let me click on add here. Suppose any uh, equipment is there, or mechanical or electrical is there. So like plumbing. Okay, plumbing equipments. So you create in the load nature and then go to load cases. Go to load cases. Choose with duplicate, and then there you give it a name. So there you can go for any shortcut like plumbing one, and the nature, it will be listed here. You can see the plumbing equipments, and from the category you have to choose. This is going to be the dead loads. So for plumbing equipments, you can apply this load that is created. Can click on OK. And if there is any element where this load will be applicable, so you go to this load option and you define this point load, line load, area load. Okay, so here we have this point load, line load, area load, and the same thing we have available for hosted point load, hosted line load, and hosted area load. So what is the difference? You have to sketch. If you choose this point load, you have to sketch. But if you go for this hosted point load, you don't have to sketch. You just choose that right beam or column. Okay, or the brace. And if you go for this also, so you just have to choose the right structural component. And for the hosted also, you have to choose the right floor or slab structural component. But for this line, you have to draw. For this area, you have to draw. Okay. So, so for your live load, it will not be the complete area of this floor, right? So for that, you just go for this area load and you draw it, that particular area where the live load is applicable. Okay. Uh, so let's go for this hosted load and then select this analytical floor, and these load is applicable. And here we have the option for applying forces. So define the forces in each direction, and any description and comments you need, and then go for this load case. So here we have the load case, define the load case. So you have the options. Okay, so this is the dead load and orient to project. That is fine. And you can also host a local coordinate system that you can mention. And now you see that we are getting this line so big, correct? So for that, go to edit type. And here we have this area force scale. So you can change this area force scale. So how much force will be applied? As per that, you will get these arrows. So area force, you can choose like 5, and distance between arrows, they're 1/2 inches. And what will be the arrowhead type? You can choose this one. Click on OK. All right. So this way we will apply loads. So you can use the point loads, line loads. You can apply it, right? The same way you can apply it. Let me go to the roof level. Let me go to the roof level. And let me go for realistic and fine. Just a second.
Sir, why we use as a boundary condition at first?
Yes, the boundary conditions, those are the supports or the condition like you need to provide for your analysis that this is at the fixed placed at the fixed point. Okay, this column is placed at this fixed point. This is fixed. The end is fixed. So you need to define with the boundary condition. And if there is any support like roller support is there, so you can go with that boundary condition.
So in that case, you at the bottom level you are showing that pin load, and in top level you create the boundary with boundary area load. So ऊपर
That
में
is
भी
the
क्या pin
load.
load कर
That
सकते
is
हो?
the ऊपर ऊपर क्या कर सकते हो?
एक्चुअली सर नीचे आपने पिन लोड दिया और बाउंड्री
नीचे
कंडीशन।
नीचे नीचे वो बाउंड्री कंडीशन दिया, मैंने नीचे ही दिया। यहाँ पे भी अप्लाई होगा, यहाँ पे भी अप्लाई होगा ना। ये तो
अच्छा।
एक कंटिन्यूअस ये है, लेकिन अगर मैं इसको इसका लेवल 1 से इसका लेवल 2 तक जाएगा, अनजॉइन एलिमेंट्स लेवल 2 तक जाएगा। ठीक है, ऐसा ऐसा होगा। फिर इसको मैं कॉपी, अलाइन टू सिलेक्टेड लेवल्स, और ये लेवल 2 के बाद रूफ ओके। ऑलराइट, सो यहाँ पे भी आएगा इसका। ये मैं इसका सपोर्ट दे रहा हूँ इसका, मैं यहाँ पे लोड नहीं दे रहा हूँ। ये इसका कंडीशन है कि ये इसका फिक्स्ड है, ये क्या है। सो यहाँ पे मैं जाके एनालिटिकल मॉडल में जाके यहाँ पे अप्लाई करूँगा, यहाँ पे भी अप्लाई होगा, सभी पे अप्लाई होगा ये, यहाँ पे भी।
मतलब
अगर
सर
ये
पहले
कंटिन्यूअस एक बीम है तो यहाँ पे अप्लाई होगा।
ओके
अगर ये
ओके
कंटिन्यूअस एक बीम है लेवल 2 से सॉरी लेवल 1 से लेवल रूफ तक, देन फिर यहाँ पे बॉटम पे ही अप्लाई होगा।
ओके।
तुम लोग क्या बोलते हैं, स्टैट प्रो यूज किए हो? स्टैट प्रो?
No, sir.
ओके, नो प्रॉब्लम। So this way we generally provide the fixed support. Fixed support, it can be fixed support or roller support or pin support, which will be the condition. And later we apply the loads, like here the area loads is applicable. So this is showing you. And for your analysis, you can create load combinations. So we are not covering
Sir,
the analysis part in Revit structure. So that can be done with another software by Autodesk, that is robot structural analysis. But we are not covering that. We're generally covering the Revit, and I'm showing you that how you can create the analysis. For analysis, how can you apply this load cases and everything. So before going to the robot structural analysis, you can make it ready. Yes, yes, go for the question.
so is this the same process for concrete structures too?
Sorry, which?
The applying loads process, point
I
load and
didn't.
area load and all.
I didn't get your point. This process is for what?
Concrete structures. Is this a
Concrete
steel
structure.
structure? Na?
Yes, yes, yes. It will be same, right?
Okay.
Okay. So before going for the load combination, before creating the load combination, you must create your loads. The way I have showed you, you must create some loads, and you will get these loads already created. And then you have to create a combination. So for that, click on add first. This is the load combination section. This is the formula section, and this is the combination usage section. When you add any combination, then only this formula section will and this combination usage section will be activated. So here you can give it a name. So you can just go for D plus L, dead load plus live load. So I'm going to show you with this only. And this is only applicable for your analysis. So before that, you were just creating it. So here you can see that the formula is there. So here you can choose like any particular one you can choose. So it will generally shortlist. So from all you can just shortlist all the dead loads. Suppose if any dead load formula is there, so you can just shortlist from it. So here we have this and select it. Make sure this load combination is selected. Then only this one will be activated. And you activate the formula, add formula with this. So right now this dead load is activated. Click on another add and there you can apply factors. So just go with that. So here you can provide everything and choose the right load. Okay, what will be the right factor for your loads. And here you can see that the factor multiplying with the load and adding another load with that factor, right? And the type is combination, right? And the state, if it is serviceability or this is the ultimate. So this is the ultimate, right? For your dead load and live load, the state will be ultimate. And usage, so usage, we haven't applied any usage, so here you can mention the usage. So like total load leakable, and you click on this set and this usage will be visible here. Okay, and then you click on OK. So this way you create your load combination. Okay, and after that you can go for your analysis process. Okay, so this is how we will do it. We have this boundary condition, we have this load option. So for this you can go like this area load. So for this area load, let me go to the roof and there I can just draw it. And for that, I will apply live load. So live load will be applicable like from this area or from this area to this area. And click on OK. And it is done. That is selected. Let me go to 3D and now you can see that is created on this particular level 1, right? So you can go to this edit boundary and let me select all this boundary. Okay, and you must set the work plane where it will be placed. So it will be placed on roof, right? It will be placed on roof. So make sure you have selected the right plane before drawing your boundary. Click on OK. And if you suppose you have forgotten to mention it, so again you can come to the edit boundary option and there you can set the work plane and then go for finish. And there it is. And for these also, you can go for the analyze tab, go for loads, line load, you can mention. Okay, so this is going to be the dead load. So the self weight load, you can go to the particular level like penthouse and loads, line load. You can just draw it from this end to this end, this way. Yeah, no problem. So you can go to the fine. And here, if it is, you need to make it visible. You can make it. But now you can see that this is the line load, which is applicable. And you can adjust these points. Okay. And go to edit type, and there you can change the linear force scale and moment scale and all. You can change it. Okay. So this way you can apply for all these. Okay, so this is all. This is all for today.
सर एक क्वेश्चन है, ये जो लोड हम लोग अप्लाई किया तो उसके बाद रिजल्ट क्या है, ये कैसे पता चलेगा?
हाँ, जैसे मैंने बोला ना कि हम लोग सिर्फ मॉडलिंग पार्ट कवर कर रहे हैं रिविट स्ट्रक्चर में, और वो उसके लिए हमारे पास दूसरा सॉफ्टवेयर है, ऑटोडेस्क का ही सॉफ्टवेयर, रोबोट स्ट्रक्चर एनालिसिस। अभी थोड़ी देर में पहले मैं बोल रहा था ना।
हाँ।
हाँ,
और
तो उसमें हम
हाँ,
लोग एनालिसिस करते हैं।
अच्छा। और ये जो लोड लोड डाल रहा हो, हम लोग लोड डिफाइन कर रहा हो, वो भी तो कुछ प्री डिफाइन रहेगा ना लोड?
प्रीडिफाइंड तो ऑलरेडी है ना यहाँ पे लोड्स।
नहीं मतलब जैसे एडिट टाइप में जाके हम लोगों का मर्जी से लोड को चेंज किया रहा हो, वो तो पहले से दिया हुआ जाएगा ना?
यहाँ पे लोड्स वगैरह है ना, तो अच्छा, वो तो हाँ, वो तो ऑब्वियसली एज पर द स्ट्रक्चरल डिजाइनर, ऑब्वियसली। तो ये जनरली बिम मॉडलर का काम नहीं होता है एनालिसिस का। ये स्ट्रक्चरल डिजाइनर जो होगा, वो ही एनालिसिस का पार्ट, वो एनालिसिस करेगा। ओके देन।